PSN College of Engineering and Technology, and now I am taking a subject is multimedia technology. So multimedia, in the sense, it is the combination of multi and media. So multi in the sense many, and media in the sense it's like an audio, images and animations, graphics, text and videos. So media is a combination of different types of media, like text, audio, images, animations, graphics and video. These are integrated together in a digital environment to present information for creating interactive applications. Okay, so next, it has some applications like education and e-learning. When we have to learn something, the multimedia applications which will be help to everyone. And then is entertainment and media. Next, business and corporate sectors, communication and social media, and then healthcare, medical training, and science and engineering, then finally military and defense. Okay, so these are the applications of multimedia. Next one is it can be used in integrations of media, interactivity, then digital representations and compression techniques, then synchronization, interdisciplinary nature, and finally high storage requirements. Okay, so next one is multimedia architecture overview. So in architecture we have some types of layers, some level of layers. So that are, first one is input or capture layer. The input layer which will be helps to use the device and methods for data collecting. Okay, then second one is processing layer. The processing layer can be convert the raw data into a usable format. Okay, then one is storage layer. The storage layer can be stores multiple level of data in a digital format. Okay, then networking layer. Networking layer, it's ensures some data from multimedia to deliver the devices across the networks. Types of multimedia data, already we know: text data, image or graphics data, audio data, video data, animation data, graphics or 3D models, finally interactivity data. Next one is text in multimedia. When we have to go for the text, first the text is first and foremost important fundamental element of multimedia. It can be used to display the whole information from the data in written format. Okay, and it is the primary medium for communication to providing these structures, instructions and descriptions, and also context the other medias like images, audio and video. Okay, next one is types of text, and we know the text types. Number one is static text, second one is hypertext, and last one is formatted text. So next one is audio to analog versus digital. So we know what is analog and what is digital. Then in analog and digital for audio, the analog audio can be sound waves. Okay, so the examples of analog audio is tape records, and it has some digital audio like it can be discrete the representation, for example of sampling and quantizations. For example MP3 audios, VAV audios, and finally AAC audios. Okay, and as we all know, what is ADC, that is analog to digital conversion. When we have to convert the signal in analog to digital, the requirement can be sampling and quantization formats. Video to analog versus digital. In video format, analog can be signals through the VHS and analog TV also, and the data can be stored as discrete frames like MP4, AVI format and MKV formats also. and the storage can be used to digital uses less space due to compressions. For example of MPEG and H.264 format also. Okay, when we have to transmit the data in analog to digital, the digital streams can be faster with better quality. That's the best advantage of video to analog versus digital format. Animation, the format of what is 2D and 3D. The 2D is in the sense it can be came from the cartoons and web animations also, and 3D as well as we know the 3D movies, 3D datas like depth and realistic movements. So for example of Pixar movies and VR. Okay, VR in the sense we all know virtual reality, and then 2D tools can be in Adobe Animate, and 3D can be Blender or Maya. Okay, then it has some applications also. For example of 2D applications, number one is advertisement, and second one is learning materials. Okay, so next one is 3D applications. As we all know, movies, gamings and simulations. Multimedia data integration. For integration in the synchronization of text, audio and video can be interactive in multimedia apps like hyperlinks and menus. Okay, what is the need of compression? So we all know the data compression. Okay, so what is the purpose of compression in multimedia? It can be reduces the storage requirements, and it will be faster data when we have to transmit over the networks. Then cloud storage cost can be most efficient for that. Next one is it can be enables the streaming services, for example of Amazon, Netflix and YouTube also. Then finally it improves the performance of multimedia systems over the networks. Then cloud storage cost can be most efficient for that. Next one is it can be enables the streaming services, for example of Amazon, Netflix and YouTube also. Then finally it improves the performance of multimedia systems. So next one is types of compression. So what is compression? Compression is nothing but when we have to compress the data for using something, that is called compression. And it has some types also. There are the two types of compressions are available in multimedia. So first one is lossless compression, and second one is lossy compression. Lossless compression in the sense when we have to compress some data, the data cannot be lost. Okay, that is called lossless compression, and it can be reconstruct from others. That's also no data can be lost. Okay, but the lossy compression is when we have to reconstruct some data, the data can be lost. That is called lossy compression. The example of lossless compression is PNG format and GIF format and zip format also. The lossy compression can be the examples of MP3 format, MPEG format and JPEG formats. So these are the types of lossless compression algorithms. So first one is run length encoding. It can be store some values and also count. Okay, so when we know the run length encoding, so run length encoding in the sense we have to simplify the data. For example, we store the consecutive repeating values as value or count. For example, we have to write the letters like this, and then we have to convert it in the run length format. Okay, so we have to count how many A's are available and how many B's are there and how many C's are there. So just we have to count and we have to write it. So this is called run length encoding. Okay, and it can be easy to implement, then also efficient for long runs. Okay, it has some disadvantages in the sense it is insufficient for complex or random data. Okay, so first one is run length encoding and second one is Huffman coding. Huffman coding is also known as variable length encoding. Okay, so variable length encoding means we have to assign shorter codes to frequent symbols, okay, and assigns longer codes to rare symbols. For example, we have to take the E value into zeros and ones and the Z can be these words. Okay, we all know the Huffman numbers also, so that type it will be enabled for the process. Then it can be applied for JPEG, MP3 and MPEG also, and it has some advantages. First one is optimal coding for simple probabilities. So next one is arithmetic coding. So arithmetic, as we all know the numbers. Okay, so the entire messages can be encoded into one fractional number. Okay, so it can be more efficient than Huffman. So we have to improve the variable length encoding. It will be enabled to arithmetic coding also. For example, it cannot be probabilities of the power of 2. Okay, so first we have to know the steps. Divide interval zeros and ones, then we have to assign some sub intervals, finally we have to encode the data. Okay, and it is a higher compression ratios. It have higher compression ratio, and then applications also JPEG and H.264. So next one is lossy compression algorithm. As we all know, what is lossy compression? Lossy compression in the sense when we have to reconstruct the data can be lost. That is called lossy compression, and it has some types. So first of all, the transform coding. The transform coding in the sense it can be concentrates the energy through the compressed data. Next one is quantization. Quantization, it is reduced the precision. Okay. இன்னும் முடியல எவ்வளோ நேரம் ஆயிருக்குன்னு பார்க்கலாமா? பாருங்க, 15 மினிட்ஸ் தானே வந்திருக்கு. சரி, ஓகே, இன்னொரு 10 மினிட்ஸ் எடுக்கணும் அப்படி தானே. இது இப்போ நான் 10 மினிட்ஸ் எடுக்கிறேன்னா இதுலேருந்து நீங்கள் கம்ப்ரெஸ் பண்ணி போடணும் தானே. அப்போ நான் ஒரு 30 மினிட்ஸ்க்கு மேலே எடுத்தால் தானே உங்களுக்கு கம்ப்ரெஸ் பண்ண கரெக்டாக இருக்கும். சரி, ஓகேப்பா. bi-level image compression refers to compressing images containing only two colors, or a foreground and a background, and it can be using some techniques like the JPEG and JPEG2 format standards. These two standards can be highly effective for bi-level images, especially text to heavy documents. Okay, so it can especially text to heavy documents by employing specialized methods for text and generic content to achieve significant file size reduction, and even allowing for lossy compression to gain greater compression ratios. And the key aspects of bi-level image compression, first one is image type. The image type, it deals with the image where pixels can only have two values, typically black and white. That's the format of bi-level images. Okay, so next one is also we know the high efficiency for black and white images, so that is the advantages of bi-level images. And it has some applications like it can be commonly used for documents, faxes, and scanned images where text and line art of prominent. Okay, so next one is JPEG standard. The JPEG standard named after the Joint Photography Experts Group is an international standard for compressing digital still images, particularly full color or grayscale images of natural scenes. Okay, and it uses a lossy compression method which significantly reduces file sizes by removing visual data the human eye is less likely to perceive. The standard defines the code, not the file format itself, which is instead defined by some standards. Okay, and it can be block based format in 8x cross 8 DCT format, and the quantization process also reduces precision. And then the key aspects of the JPEG standards, for first one is lossy compression and continuous tone images. Next one is key techniques. So next one is JPEG 2000. So JPEG 2000 is a wavelet based image compression standard. It can be developed by Joint Photographic Experts Group. It can be developed by the JPEG format. Okay, to overcome the limitations of the original JPEG standards, and it can be used for DWT instead of DCD. It will be supports both lossy and lossless compression also, and then it have some scalability, quality, and then in JPEG 2000, how it works? In JPEG 2000 we know how it will be work. So it has some formats. So first one is wavelet platforms, and when we have to convert the data into JPEG 2000, it can be used for the wavelet platform. Next one is chilling method, and then one is quantization, and last one is arithmetic coding. So we all know GIF and PNG methods. So we all are used in Android mobile. We all having some WhatsApp, then Instagram. It can be available in that. So GIF, in the sense, it can be 256 colors having, and it supports some animations also. Okay, then PNG is it supports for transparency, and it is the lossless compression also. Okay. Next one is MPEG. MPEG in the sense moving picture experts group. Okay, it is an so MPEG is an organization that develops international standards for compressing digital audio and video. It can be enabled for more efficient storage and transmission of multimedia files for applications like digital TV, DVDs and video streaming also. Okay, so first of all we know the basic standards. So first one is MPEG 1 and MPEG 2, and now the advanced version will be the MPEG 4. Okay, so in MPEG 1 the formats are in CD format and MP3 audio format, and it can be upgraded from the digital TV and DVD, and finally it is the streamings and video conferencing also. So that is the new advanced format. And finally we know the H.264 or AVC. So it is called high compression, then Blu-ray, and it will be used for YouTube also. So these are the standards of MPEG format. Okay, so next one is what are the applications or what are the applications are available in the image compression. First one is web images, next one streaming media, and then medical imaging, digital cameras and mobile applications also. Okay, so the next topic is color models. Okay, so we all know the rainbow colors, which are in the colors. So first one is the first and foremost method of colors. We should know the RGB colors. So RGB in the sense red, green and blue. Okay, so this is called additive models. Okay, so the color models are used to represent the mathematical system colors. Okay, so first one is additive colors. Additive colors in the sense, as we all know, the red, green, blue, it is used for screens. Next one is subtractive models. So subtractive models in the sense CYMK. So CYMK in the sense cyan, magenta, yellow, and K in the sense it is a key color, for that is black color. So these subtractive models are used for printing sums. Okay, next one is perceptual model. Then it can be used for image processing, editing and display something. Okay, so in RGB color model, it has some the components are red, green and blue. So what is the additive mixing for this model? We all know white. Okay, when we have to adding white in the RGB model, we all know the some subtractive models also. Okay, we all get the subtractive models, and it can be used for monitors, cameras and scanners. Okay, next one is CMYK color. CMYK in the sense it have the components of cyan, magenta, yellow and black, and it all can be mixing, the color will be black. When we have to mix the black color in CYMK models, we can create some new models also. Okay, so it is used for printers and publishing. So these are the advantages and disadvantages of color models. In RGB we have to wide gamut, and it can be display friendly, and then RGB does not working for printer. Okay, next one is CYMK. In CYMK it can be accurate print reproduction, and the limited colors only visible in the screen, it will be the limitations. And finally HSV in the sense it can be matches human perceptions, and it will be complex for computation also. So that is the disadvantages of HSV model. So in previous we must know what is HSV color. So HSV in the sense here, HSV in the sense hue, saturation and value. So HSV color represents a color using three components, that are the hue, saturation and value. And Q can be defines the pure color, okay, like green, red or blue. Saturation, the purity of the purity or intensity of the color. And finally the value, which is the lightness or brightness of the color. And it is a digital color model favored by artists and designers for its for the way of describing colors, similar to how humans perceive the pigments. Okay, as multimedia hardware and software for capturing, creating and displaying audio and video, then graphics including microphones, scanners, monitors and speakers. Okay, so multimedia software includes operating systems and applications like Photoshop, and then Premiere Pro, and then finally PowerPoint, which will be provide the instructions that control the hardware to produce some multimedia content. Okay, so it have some it will be refers to input devices, output devices, and then processing and storage. And finally the multimedia software is the set of instruction and programs that direct the hardware to perform a specific tasks. Okay, and in multimedia the input devices are camera and microphone and scanners, and output devices, as we all know, the monitors, speakers and projector also. Okay, and then multimedia databases, the databases in the sense it can be stores the data from the multimedia, which is through the text, images, audios and videos, and it can be requires a large number of storage capacities, and it will be support the indexing and retrieval format, and the metadata for efficient searching also. And then the applications of databases is digital libraries and e-learning methods. Next one is virtual and augmented reality. Virtual reality can be creates the entire virtual worlds, and it's hard to differentiate between what is real and what is not. Okay, and this is the experienced by wearing VR headsets. Okay, and then AR in the sense augmented reality. Augmented reality is a combination of real and virtual worlds, and it lets people to interact with both the real and virtual worlds and distinguish between the two. Generally it is the best experienced by using a smartphone. AR can be fully immersive to digital environment, and AR in the sense it enhances the real world with digital overlay. In number of flavors. For example, so in education, multimedia is a combination of text, images, audio and video, and finally animations. It has been shown to enhance students' engagement and knowledge retention. The research has demonstrate that combining words and pictures, it will be improves learning more effectively than using words alone. Okay, so it can be interactive tutorials with the text, audio and video, and it will be used for classrooms and we know the smart classrooms, it all are available, it all are only works with the multimedia in medicine. In medical formats, we all know the importance of multimedia. It is used for MRI scan and CT scan visualizations and telemedicine also. For business, it can be used for video conferencing and presentations. And then in entertainment, for example of movie streaming platforms like Netflix, Amazon Prime, and then gaming also. So these are the uses of medicines. Okay. So finally, what are the future of multimedia technology? Currently we are using the streaming platforms like YouTube and Netflix, and next we have to improve the cloud multimedia storage access, and for the recent technology AI powered finally multimedia integrates the text, images and audio and video animations into a unified platforms, and the compression techniques like lossless and lossy compressions can ensure the efficient storage and transmissions for the data. And finally, we all see these standards like JPEG, MPEG, PNG format, MP3, and then H264 make multimedia universally accessible. So the applications span across education, business and medicine, entertainment and researchers. So these all are about the content of multimedia technology. Okay, so thank you.